So we're right on the edge of a massive shift in what AI can actually do. For a while now, we've gotten used to AI that can talk to us, write things, even create images. But we are now entering the era of AI that acts. We're talking about autonomous AI agents. And believe me, they are about to become a whole new kind of workforce. You've been there, right? You ask an AI to help you plan a trip, and it spits out this amazing, detailed itinerary. But then you have to go and actually book the flights or serve the hotel and get the rental car. It can give you the blueprint, but it can't do any of the building. Well, that exact frustration is what AI agents are here to solve. And this really is a fundamental change in thinking. For the longest time, AI has been pretty passive. You give it a prompt, it gives you back a response. But these new autonomous agents, they're active. They don't just tell you things. They take that information and actually get stuff done. They can tackle complex, multi-step problems all by themselves. So how in the world do they do it? What actually makes an agent, well, an agent? Let's pop the hood and take a look at what these systems are really made of. Okay, so what is an AI agent really? It's super important to get this. It is not just another language model. Not at all. It's a whole system. It starts with a powerful model, then it gives that model a set of tools to interact with the world, and it wraps the whole thing in what's called an orchestration layer, so it can just keep working towards a goal. Let's break those three pieces down. First up, you've got the model. The easiest way to think about this is as the agent's brain. This is the core language model, like a Gemini, that's doing all the heavy lifting, the reasoning, the planning, the decision-making. It's the intelligence at the center of the whole operation. But of course, a brain isn't much use if it can't interact with anything. And that's where the tools come in. These are the agent's hands. We're talking about APIs, bits of code, connections to databases, basically anything that lets the agent's thinking actually cause an action out in the real world. And finally, you need something to connect that brain to those hands. That's the orchestration layer. Let's call it the nervous system. This is the process that's running the whole show, managing that constant operational loop, handling the agent's memory, and deciding when it's time to think and when it's time to act. So we've got the components, the brain, the hands, and the nervous system. Now let's see how they all work together. How does an agent actually think its way through a problem from start to finish? It really all comes down to this continuous loop. It's a cycle. It starts with the mission it gets from a user. Then it scans the environment to get all the context it needs. Based on that, it thinks and comes up with a plan. Then it acts, using one of its tools to execute a step. And here's the really crucial part. It observes the result of that action, learns from it, and then repeats that whole cycle until the job is done. Let's make this concrete. A user asks, "Where's my order?" A simple chatbot might just search a database, but an agent thinks first. It actually creates a little plan for itself. First, I need to identify the order ID. Second, I'll use that ID to check an external shipping API. And third, I'll pull all that info together and report the final status. It follows that plan step by step to give you a complete answer. And this brings us to a really core idea. The AI model has something called a context window. Just think of it like it's short-term memory. It can only focus on a limited amount of information at any one time. So the real skill, the real art of an agent is how it curates that memory, constantly deciding what's important from the user's request, its tools, and its own past actions. That's why this quote is so perfect. An agent is a system dedicated to the art of context window curation. Now, not all agents are created equal. Just like with any technology, they exist in a whole spectrum of capability. You can kind of picture it as a ladder, where each rung you climb represents a huge leap in power and complexity. So at the very bottom of the ladder, level 1, we have what you could call the connected problem solver. This is the simplest kind of agent. Its main skill is knowing what it doesn't know and then using a tool, like a Google search, to go find real-time info that wasn't in its training data. For a question like, hey, what was the score of last night's game? Take a step up to level 2, and you get the strategist. This is where real planning starts to happen. It can handle a multi-step goal, like find a good coffee shop halfway between these two addresses. It does something called context engineering, which is a fancy way of saying it intelligently uses the answer from one step, like finding the halfway point, as the input for the next step, like searching for coffee shops. It chains actions together. Now things get really interesting at level 3, the collaborative multi-agent system. At this point, you stop trying to build one single super agent that knows everything. Instead, you create a whole team of specialists. You have a manager agent that gets a complex goal, like, say, launching a new product, and it delegates all the subtasks to a marketing agent, a research agent, and a web development agent. And then, at the very top, level 4, we get to the real frontier, the self-evolving system. Okay, imagine a handyman who realizes he needs a specific tool he doesn't have. Instead of just stopping, he goes and builds the exact tool he needs on the spot. That's a level 4 agent. It can actually identify gaps in its own capabilities and then autonomously build new tools or even whole new agents to get the job done. So we get the components, we get the process, we get the different levels of power, but what's the big picture here? What does all this actually mean for us and the world we live in? And let's be super clear, this isn't science fiction. These advanced agents are already here. Google has a co-scientist agent that's literally working as a research partner for humans, coming up with and testing new scientific ideas. At the same time, you have things like AlphaEvolve, discovering brand new computer algorithms, ones that outperform designs that took humans decades to come up with. This also completely flips the script for the people who build these systems. A developer is no longer a bricklayer, painstakingly coding every single step of the logic. Now they're more like a director. Their job is to set the scene with good instructions, choose the right cast of tools, and then guide this autonomous actor to give the right performance. When it comes right down to it, this is the main takeaway. Agents aren't some totally different technology from the language models we already know. They're the natural evolution. They're the thing that takes all that raw reasoning power and makes it genuinely useful and active inside a piece of software. All of this leads to one final, pretty mind-bending question. As these agents become our collaborators, tireless, incredibly fast, and adaptable, we have to start asking ourselves, what happens when your most effective teammate isn't human?